Discover the real power behind heavy industries where metal meets machine, and mining fuels the heart of global manufacturing progress. The relining of a grinding mill is one of the most critical maintenance operations in the mineral processing industry. It restores the mill's grinding efficiency, reduces downtime, and extends its service life. The process begins with mill preparation, where all safety procedures are implemented. The power supply is isolated, and the interior of the mill is inspected. Workers ensure that all necessary tools and equipment are ready for use before starting the relining work. The first major step is the feed chute transport, in which the feed chute is carefully disconnected and moved away from the mill using cranes or lifting equipment. This allows clear access to the mill's interior. Next, the mill relining machine is installed. This powerful, hydraulically operated device plays a central role in handling the heavy liners and positioning them precisely inside the confined mill space. Once the setup is complete, the worn liner removal process begins. Technicians use elevating platforms to reach the upper parts of the mill shell safely. Old liners are loosened and dislodged during the knocking in phase, where mechanical or hydraulic tools are used to break their grip from the shell. The removed liners and debris are then taken out during the mucking out stage, ensuring the inside of the mill is clean and ready for the new components. To assist in this operation, ozone worn liner lifting tools are used. These specially designed lifting devices safely extract heavy liners, minimizing manual handling and improving safety. After removal, the mill relining machine is used again for new liner placement. Each liner is lifted, aligned, and carefully seated in its designated position, with the help of hydraulic arms and operator guidance. For accurate fitting, the Thunderbolt recoilless hammer combined with T-Mag's magnetic tools is used to knock liners securely into place without damaging the shell. After placement, mill inching is performed. This involves slowly rotating the mill to bring the next section into position for relining. When all liners are installed, the team performs liner bolt fastening, securing them tightly against the mill shell. The feed chute replacement follows, reinstalling it into its correct alignment. Finally, the crew conducts liner bolt torquing, ensuring all bolts meet the specified tension values. With a final inspection and clearance, the elevating platforms are removed, and the mill is prepared for operation. The Russell Multi-Wheel Feed Chute Transporter is an advanced material handling vehicle designed to move large, fully loaded feed chutes in mineral processing plants. During operation, a loaded chute imposes one of the highest floor loads in such facilities. To address this, RME developed the Multi-Wheel Transporter series, which significantly reduces point loads by using load distribution technology and multiple independently supported wheels. This innovative design allows the feed chute to be repositioned anywhere on the plant floor while maintaining low and evenly distributed pressure. The system supports the chute centrally, ensuring balanced wheel loading even on uneven surfaces. As a result, the transporters greatly decrease structural stress and can lead to substantial savings in floor construction costs. RME offers these transporters in several capacities: 40, 60, 80, and 100 tons, making them suitable for a wide range of heavy-duty mineral processing applications. Copper Mountain Mining Corporation, located near Princeton, British Columbia, is one of Canada's leading open-pit copper producers. Its greatest achievement was the installation of the Raptor 2000, the world's largest operating cone crusher, built as part of a $40 million secondary crushing facility. This project was completed on time and on budget, despite requiring highway closures and bridge modifications due to the crusher's massive size. The new crusher has significantly improved production by reducing ore to finer sizes, allowing higher grinding and copper output. With $120 million invested in mobile mining equipment and advanced computerized systems, Copper Mountain now mines 175,000 tons per day, ensuring efficiency, growth, and sustainable long-term operations. The Haas UMC 750SS is a super-speed, 5-axis universal machining center developed for rapid and precise production of complex and multi-sided parts. As one of Haas Automation's advanced models, it represents the company's commitment to combining speed, accuracy, and flexibility in modern manufacturing. The SS designation stands for super speed, highlighting performance enhancements compared to the standard UMC 750, such as a higher spindle speed, faster tool changes, and quicker trunnion rotations. Designed for both production environments and job shops, the UMC 750SS is a true workhorse capable of delivering high productivity. It supports both 3+2 machining, where the tool and part are positioned in 5 axes, and full 5-axis simultaneous machining, enabling complex contouring and efficient multi-face operate-ons without manual repositioning. This capability is especially valuable in industries like aerospace, automotive, and precision engineering. At the heart of the machine lies a 15,000 RPM inline direct drive spindle, powered by a 30-horsepower vector drive system. This high-speed spindle ensures smooth, precise cutting and excellent surface finishes, even on tough materials. The integrated dual-axis trunnion table, featuring a 500 mm diameter platter, offers exceptional versatility for part fixturing, while maintaining optimal tool clearance during operations. As a super-speed model, the UMC 750SS achieves significantly faster rotary and linear motion, reducing cycle times and increasing overall throughput. The Haas CNC control system further enhances operator efficiency with its intuitive interface and real-time process monitoring. It simplifies programming and operation, making advanced 5-axis machining accessible even to less experienced users. In addition, the UMC 750SS includes several advanced software technologies as standard wireless intuitive probing system for quick setup and in-process inspection, dynamic work offsets and tool center point control to simplify part alignment and programming. high-speed machining for superior accuracy and smoother motion control. Overall, the Haas UMC 750SS is a high-performance 5-axis machining center engineered for speed, precision, and reliability, making it a preferred choice for manufacturers seeking to boost productivity and maintain top-quality standards in complex part production. The WFL M120 MILLTURN is a high-performance 5-axis turning, drilling, and milling center designed for complete machining of large, complex components in a single setup. Its advanced 5-axis capability enables precise rotational movements around the X, Y, and Z axes, allowing intricate shapes to be machined from multiple angles without repositioning. Equipped with powerful main and milling spindles, the machine delivers exceptional torque and precision, making it ideal for processing tough materials. By integrating several operations, turning, drilling, and milling into one cycle, the WFL M120 ensures reduced setup time, higher efficiency, and outstanding accuracy when machining demanding parts such as centrifugal compressor shafts. The Nurissa MC150B is a modern mechanical section bending machine designed to bend a wide range of metal profiles, bars, and tubes with precision and ease. This versatile machine represents a combination of strength, reliability, and flexibility, making it ideal for workshops engaged in structural steelwork, metal fabrication, and custom profile production. It enables smooth and accurate bending of materials such as steel, aluminum, brass, and stainless steel, ensuring high-quality results without damaging or contaminating the surface of the workpiece. To bend a flat bar, the operator must first position rollers number 3 and 5 in their fully adjusted positions. Then, washer number 2 and nut number 1 are placed, and the top handle is lowered until it comes into contact with the material. The machine is moved to the right, and the handle lowered carefully without applying direct pressure to the bar. This movement is repeated alternately to the left and right until the desired bending radius is achieved. For bending along the edge of a bar, the same rollers are used, only the distance between them is adapted according to the material's size. Using a 6-meter bar, the operator can produce several rings of identical diameter by cutting the bent piece into sections. When bending a square section bar, roller number 4 is placed along the side of the material to be bent. Then, roller number 5, washer number 2, and nut number 1 are added and manually adjusted to hold the workpiece securely. The machine also includes side correction rollers that allow straightening the profile if necessary. The same rollers and procedure apply to bending round bars of different diameters, ensuring uniform curvature throughout the process. For bending square or rectangular tubes, rollers number 4 and 5 are combined and adjusted to fit the tube size. The nut should always be tightened by hand rather than using a spanner, as the tube expands during bending and excessive pressure could cause damage. The MC150B ensures smooth execution of bends for U profiles, both inwards and outwards, thanks to its stable structure and well-designed roller system. When working with T profiles, roller number 5 is placed with its shoulder facing inward, while roller number 3 with its rounded edge faces inward on the 2 lower axles. The upper rollers are positioned completely flat, ensuring even pressure distribution. If the profile is at an angle, the roller setup remains the same as for T profiles. The 2 side corrector rollers are essential in straightening the bent profile to achieve a uniform and visually perfect result. Nurissa also offers special rollers made of synthetic material SUN for bending delicate metals, such as aluminum, stainless steel, or brass. These rollers prevent contamination and scratching, allowing precise and clean bending. For small tubes, 2 channels can be machined on a single roller, ensuring versatility and efficiency. For round metal tubes, hardened steel rollers with a Rockwell hardness of 58 are used to withstand the pressure and ensure long service life. Each tube must fit perfectly into its channel to obtain the best results. Moreover, Nurissa manufactures custom rollers for special profiles and large radii. When dealing with height restrictions or large workpieces in a workshop, the MC150B machine can be tilted to facilitate operator access and make handling easier. In conclusion, the Nurissa MC150B mechanical section bending machine is a highly efficient and adaptable solution for bending various metal profiles. It combines mechanical precision with user-friendly operation, ensuring consistent, high-quality results. Its design emphasizes safety, accuracy, and durability, making it an essential piece of equipment for any professional metalworking facility. At the San Francisco mine in Mexico, operated by Operaciones Mineras Peel, a powerful Caterpillar 993K wheel loader is seen in action loading material into a Caterpillar 777G mining truck. The Cat 993K, one of the largest wheel loaders in Caterpillar's range, is designed for heavy-duty mining and quarrying operations. Its massive bucket and advanced hydraulic system allow it to handle large volumes of material with speed and precision. In this operation, the loader approaches the pile, digs deep into the material, and efficiently fills its bucket. The operator then maneuvers the machine with precision to position it alongside the Cat 777G truck. With a smooth lift of the arm, the loader dumps the material into the truck's large bed. The entire process demonstrates excellent coordination between the two machines, minimizing cycle times and maximizing productivity. The Cat 777G, known for its durability and high payload capacity, quickly receives the load and prepares for transport within the open pit mine. Together, these two caterpillar giants exemplify the efficiency and reliability of modern mining operations in Mexico. At the Santa Lucia coal mine, two wheel loaders work together to feed raw material into a large screen. The wheel loaders continuously transport the coal and dump it into the feeder, where the screening process begins. Inside the machine, the material is sorted by size, allowing finer coal to pass through while larger pieces are removed. This screening process ensures efficient sorting and preparation of the coal for further processing and shipping. The hot rolling process is a crucial stage in steel manufacturing, where steel slabs are plastically deformed at extremely high temperatures to produce long, flat strips used in products such as steel plates, coils, and sheets. This process involves several key stages, including reheating, rough rolling, coiling, finishing, cooling, and final coiling. Each stage demands precise control and extensive experience to ensure the production of high-quality steel with the desired mechanical and surface properties. The process begins with a steel slab that has been continuously cast to the required dimensions of width, thickness, and weight. Before rolling, the slab must be heated in a reheating furnace to approximately 200 degrees Celsius. Two walking beam furnaces feed the slabs through the oven, ensuring uniform heating throughout their length. Proper heating is critical, as insufficient temperature can lead to incomplete dissolution of carbides and nitrides, resulting in poor mechanical properties. Once reheated, the slab is transferred to the roughing mill. During transportation, the hot steel reacts with oxygen in the air, forming a layer of mill-scale iron oxide on its surface. If this oxide layer is not removed, it can be pressed into the steel during rolling, leading to defects. To avoid this, high-pressure water jets at 160 bars are used to perform mill-scale cleansing, effectively cleaning the surface before it enters the rolling stands. In the roughing mill, the slab's thickness is reduced dramatically, from about 220 millimeters down to approximately 30 millimeters. This reduction is achieved using a powerful 4-high rolling mill, which consists of 2 backup rolls made of cast steel and 2 smaller working rolls that come into direct contact with the material. The working rolls must have extremely smooth surfaces and withstand high temperatures and wear. Typically, the steel passes through the rolls 5 times, with intermediate descaling to maintain surface quality. Vertical rolls are also used to control the width of the slab. After rough rolling, the product is known as a transfer bar. Next, the transfer bar is coiled in a coil box, which serves 2 important purposes: saving space and ensuring temperature equalization between the bar's ends. When uncoiled, the bar's temperature is around 1050 degrees C. The ends are trimmed, and the bar undergoes another descaling before entering the finishing mill. The finishing mill consists of 6 stands arranged as 4 high mills. Here, the transfer bar, now called a strip, is rolled to its final thickness, typically between 16 millimeters and 1.8 millimeters. Between the stands, up loopers help regulate the line speed and tension. adjusting the strip's profile and flatness dynamically. The first stands primarily control the profile, while the later stands refine the flatness, ensuring that the strip meets exact dimensional and surface requirements. After finishing, the strip passes through a cooling section, where the cooling rate is carefully controlled to achieve the desired microstructure and mechanical properties. Finally, the strip is coiled at temperatures between 150 degrees Celsius and 750 degrees Celsius, depending on the required steel grade. Once cooled, the hot-rolled coil can be sold directly or sent for further processing, such as cold rolling, to produce more precise and smooth steel products. Through this combination of heat, pressure, and precision, the hot rolling mill transforms solid steel slabs into versatile and high-quality materials used across the global manufacturing industry. The Trump True Laser Tube 3000 is an advanced laser cutting system designed for fast, precise, and flexible processing of tubes and profiles. It offers efficient loading parallel to production, ensuring continuous workflow and minimal downtime. The machine delivers high-quality laser cutting across a wide range of materials, shapes, and sizes, including L profiles, U profiles, and flat steel sections. Equipped with intuitive software, the True Laser Tube 3000 provides easy handling and operation, even for complex geometries. Its easily adjustable tube support accommodates various diameters and shapes, guaranteeing stable positioning throughout the cutting process. The system integrates seam line recognition, both on the inside and outside of the tube, enabling automatic and precise alignment for perfect cut accuracy. The setup-free clamping system ensures that all tubes are held securely and consistently, contributing to reliable, high-quality results. For material removal, the machine offers several options: part removal flaps, guide rollers, and direct collection of small components into boxes. Additionally, its excellent accessibility allows for convenient manual loading and unloading when required. Overall, the True Laser Tube 3000 represents a perfect combination of speed, precision, and user-friendly operation, ideal for manufacturers seeking productivity and flexibility in modern laser tube cutting. The EcoStat 3 is a portable hardness tester designed for fast and accurate metal hardness measurements. Before testing, calibration must be done on the EcoStat 3 test block, placed on a solid base. The sample surface should be flat, smooth, and clean, with a maximum roughness of 2 microns to ensure precision. After selecting the material and hardness scale, the user presses and releases the probe to complete the test. The device provides real-time guidance and allows easy conversion between hardness scales. Suitable for pipes, vessels, and metal rolls, EcoStat 3 enables reliable on-site hardness testing without laboratory preparation. The impressive replacement and exchange operation of the hydraulic cylinders responsible for rotating the Zelate bridge. 2 brand-new double-rod hydraulic cylinders, each weighing 32 tons, with a maximum force of 232 tons and a stroke of 3,800 millimeters, were delivered to the site through exceptional transport. These cylinders had been pre-assembled in a completely new cardanic suspension system and equipped with newly designed contact points to ensure perfect alignment and smooth operation. Upon arrival in Zelate, the replacement work was carried out by a multidisciplinary team of experts in mechanics, hydraulics, and heavy lifting. The bridge was precisely lifted with centimeter-level accuracy to allow for safe removal of the old cylinders. The first new hydraulic cylinder was carefully positioned and connected to the bridge, while the second one was being installed on the opposite side. Throughout the process, meticulous synchronization and control were required to maintain the balance and stability of the rotating structure. This complex operation demonstrated advanced engineering coordination and the capability of Van de Zonde and Vameco teams to execute heavy mechanical replacements under tight tolerances. Once completed, the new hydraulic system ensured reliable, efficient, and long-term rotation performance of the Zelate bridge.